Section 3.4, translating and stretching graphs. So the first thing we want to talk about are vertical translations. So basically, I'm going to give you a basic function, and we're going to apply some different rules to it that will move it around and shift it different ways. So these will shift it up or down vertically. So if we say that f is a function and k is a positive number, then the graph of y equals f of x plus some constant k is identical to the graph of y equals f of x, except that it has been translated k units up. Likewise, if you subtract a number from the end of the equation, what do you think that does to it? It moves it k units down. So you can see over here, this mid function, the pink function, is the original. Okay? Whatever it is. That's the original function. Well, if I add a constant to the end, it moves it up. But if I subtract a constant from the end, it shifts every point that many units downward. For our first example, we would like to use translations to graph. G of x equals the absolute value of x minus 2, and h of x equals the absolute value of x plus 3. Now, to start even talking about these, we need to talk about what we call the parent function. The parent function is the original function before it was shifted, and it'll be a very basic function. So the parent function of these two guys, if you had to guess, what would you guess it was? Y equals absolute value of x, yes. Y equals absolute value of x. That's the parent function. It's just plain old. It hasn't been shifted up, down. Nothing's been done to it. It doesn't have any coefficients. It's just the most basic absolute value equation there is. That's called the parent function. Okay? So we're going to go ahead and we're going to graph the parent function, and we're going to do that just kind of from memory. And over time, you're going to get very, very good at these parent functions, and you'll be able to do those without a whole lot of effort. We know that the absolute value of x makes what shape? A V, and it starts as the vertex. Where's the vertex for absolute value of x? 0, 0. And then if I put 1 in, I get the absolute value of 1 is 1, 2 is 2, 3 is 3. Negative 1 would be 1. Everyone understand where those points came from? If you don't, you need to ask now. Do you understand where I got them from? I was just substituting basic numbers into the parent function, and that produced what we call the parent graph. And usually, I like to graph the parent graph dotted. That helps me kind of keep them separate. Then I'm going to look at part A here, and I'm going to say that the absolute value of x minus 2 is exactly the same as the absolute value of x, except that every point has been shifted how many units? Negative 2 units. So we say that would be a translation of down 2. So we're going to take every point on the parent and we're going to move it down 2 units. That's all we're going to do, and that's how we're going to graph the absolute value of x minus 2. So this point drops down 2, down 2, down 2, down 2, down 2, down 2, and finally down 2. So there is the graph of y equals the absolute value of x minus 2. And of course, you're all holding graphing calculators, so you could certainly check that, right? You could type it into y equals, you could graph it, you could check it. The idea behind this is to help graphs make more sense to you. When you immediately look at something, if you see it as a parent graph that's been shifted, it should start to make more sense to you than if you just have to start over every time with a completely new table of values. So it's designed to help your visual understanding of graphs just get a little better. So it's just a second way of graphing. We've graphed by finding the vertex and by finding a table before, right? Well, now we're going to talk about graphing from parent graphs and shifting. So now let's talk about the absolute value of x plus 3. This guy, the absolute value of x plus 3, is the same as the parent, except it has been shifted up 3 units. So this is your vertical translation there. So we take every point on the parent and we move it up 3 units. 1, 2, 3, 1, 2, 3. 1, 2, 3. 1, 2, 3. This gets old. Maybe next time we'll only put 3 to 5 points instead of all of these. 1, 2, 3. 1, 2, 3. So there is y equals the absolute value of x plus 3. You can see how those two compare to their parent. So for now, let's just say that we'll graph the parents dotted and the other guys, the translated graphs, we'll graph them solid and in different colors. Once you have a graph of vertical translations and how they affect the graph, now we need to talk about horizontal translations. Horizontal translations take every point on the graph and they shift them either left or right. You have to be really careful with horizontal translations because they produce the opposite effect of what your brain naturally thinks. For example, if you take the parent function, okay, and you change the x with a parentheses x minus a number, like so say right here, x minus say 3 or 5, instead of shifting to the left, because we typically think of the negative direction as the left, it actually shifts it to the right. And then if you add something inside parentheses, instead of shifting it to the right towards the positive x direction, it actually does the opposite and shifts it to the left. So just to make sure we understand, if I take the parent of y equals x squared, that's our parent function, and I change the x to a parentheses x plus 2 squared, will that move it to the left 2 units or to the right 2 units?
The left.
The left. It's basically the shift is whatever makes the parentheses 0. So what makes this parentheses 0? Negative 2. And negative 2 left right would be to the left. So we say it has a horizontal translation or a horizontal shift of negative 2 or left 2. If I take that same parent function and I change it to parentheses x minus 7 squared, that's going to make a horizontal shift of how many units?
To the right 7.
Positive 7, which would be to the right 7 units. So you have to be really careful when you're identifying the horizontal shift. So we're going to say it has a horizontal shift or translation of positive 7, which would actually be to the right 7 units. So those are the ones that people are usually going to mess up if they're going to have any trouble. It's going to be the horizontal that they're going to get backwards. So be really, really cautious there. For this example, we want to graph the absolute value of x minus 4 and the graph of absolute value of x plus 2. And we want to do it using parent functions rather than finding the vertex and making a table of values. So the first thing we need to know is, what is the parent function? Parent function is y equals, or f of x equals, well, what's the basis here?
Absolute.
Quadratic, absolute value, cubic. It's just an absolute value. So the basic absolute value is just plain absolute value of x. That's your parent function.
Even if the translation's inside the...
It still has the same parent function no matter where the translation is. So basically, if you remove all the numbers, okay, from there, and you leave just the symbols and the variable, what do you have? Okay? So if you remove the shifts, what do you have left? So you have y equals absolute value of x. Let's go ahead and drop that on the graph. We know that y equals the absolute value of x has a 0, 0, 1, 1, 2, 2, negative 1, 1, negative 2, 2. So there's our parent function. So now let's look at part A. Part A, does it have a vertical shift? A vertical shift would occur outside the grouping symbol. So it would occur over on the end here. Does it have a vertical?
No.
No, there's no vertical shift. So we'll say that that one is 0. So there's a 0 vertical shift. But there's a horizontal shift of positive 4. So positive 4 means it's going to move to the right 4 units. So that guy has a horizontal shift of positive 4 moving to the right 4 units. So to graph this, I simply take the original parent function and move every point on it to the right 4 units. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. So there is the graph of y equals the absolute value of x minus 4. What do you say now we look at part B? Does it have a vertical shift?
Yes.
Vertical shift?
No.
What's its vertical shift?
0.
We say none or 0. It's not being shifted up or down. The change is occurring inside the parenthesis, inside the grouping symbol there. So that means it's going to have a horizontal shift of -2, or in this case, we'll say left 2 units. And you can list translations as positives, negatives, or you can describe them up, down, left, right. It doesn't matter. So just be careful with them. So that means it'll take the parent function and shift every point on it to the left 2 units. So we'll relocate all of those points, including the vertex. And there is the absolute value of x plus 2.